Hello friends, I welcome you all to this new video on application of normal distribution. This particular video, which is in the series of normal distribution, is the third video on this particular topic. I hope you must have watched the previous two videos on application of normal distribution and the concept of normal distribution. Before going to this particular video on application of normal distribution, I suggest all the viewers to watch the previous two videos on application of normal distribution, and the first one as it is on the concept of normal distribution and the characteristics or properties of normal distribution. The watching of the previous two videos will help you to understand what are the different application of normal distribution, and whatever application or whatever problems that I am going to discuss in this particular third video, that one also you will understand in better way. In continuation of the second video on normal distribution, in this particular video, I will be discussing on different other application of normal distribution. I will take up different examples from the real life situation where we can apply the characteristics of normal probability curve and solve the problems based on normal distribution curve. The properties of normal probability curve will be used to solve this problem, and majority of the problem in the field of social sciences and in the field of education are related to normal distribution curve. So I hope you will enjoy this video and it will help you to understand what is normal distribution and how normal distribution properties can be used or utilized to solve different problems based on normal probability curve. So keep watching. Okay, as we already know that normal distribution is based on unique normal curve. That is a normal curve with mean equal to 0 and sigma equal to 1 and n also equal to 1. But practically this is not the situation which arises. Whenever the mean value is different from this particular value, whenever n is very large and sigma is also different, then we basically use certain formula to convert the raw scores into some standard scores. This we have discussed in the previous video also. So let us revise that one. So to solve the problems based on normal distribution curve or normal probability curve, we need to use certain formulas, and we have to use a table which I already discussed in the previous video, the table of area under the curve and the formula for Z score. So as we are seeing in this particular formula of Z score, Z equal to x minus m by sigma, or Z equal to small x by sigma. So small x is capital X minus m. So here Z is the standard score, X is the raw score. Whatever data we have collected, from there we can get the raw scores. M is the mean of the X scores or the data, whatever data we have got, and sigma is the standard deviation of the X scores. So by putting these values, we can get the Z score. To understand this formula in better way, let us take one example. If mean of a distribution is 25, sigma is equal to 5 and x or the raw score is 30, then we can have the Z score or the standard score as Z equal to x minus m by sigma. So we can get Z equal to 1 sigma. This particular formula we have used in several problems in the previous video also. In this particular video also, this formula has got different uses. So this is one of the major formula which we need to remember while solving problems based on NPC or normal distribution curve. The other main object or table which is used for solving the problems based on this formula is the table of area or percentage of the entire distribution in correspondence to the Z score or values. The table of areas of normal probability curve are referred to find out the proportion of area between the mean and the Z score. Though the total area under the NPC is 1, but for convenience and for the ease of comprehension and interpretation, the total area under the curve is taken to be 10,000. As this makes it easier with which fractional part of the total area may be then calculated.
The first column of the table x by sigma gives distance in tenth of sigma measured off on the baseline for the normal curve from the mean as origin. In the row, x by sigma distance are given to the second place of the decimal. To find the number of cases in normal distribution between the mean and the ordinate erected at a distance of 1 sigma unit from the mean, we go down the x by sigma column until 1 is reached. And in the next column under point 0, we take the entry opposite to 1, namely 3413. This figure means that 3413 cases in 10,000 or 34.13% of the entire area in the curve lies between the mean and 1 sigma unit. Similarly, if we have to find the percentage of the distribution between the mean and 1.57 sigma, say we go down the x by sigma column to 1.5, then across horizontally to the column headed by 0.07 and note the entry 4418 or 44.18% of the entire cases of 10,000 lies in between mean and 1.57 sigma unit. This table is thus of major use whenever we are in the process of solving problems based on NPC. So this particular table we will refer repeatedly whenever we will be solving problems based on normal probability curve. So this particular table and the formula for standard score or Z score are the two important aspects whenever we are solving problems based on normal distribution. I hope you have understood how to follow this table. If you have not understood or you need practice, then you can repeat this. You can rewind the video and again watch it repeatedly so you will be able to follow how you are using this particular table. Basically, any good book of research has this table, and once you are able to use this particular table and follow it, then you will be able to solve problems based on normal distribution. Okay, after understanding the important formula to be used for solving problem on normal distribution, and also after understanding the table of area under the curve, that is the proportion of the area under the curve for a particular sigma value, now we will progress further and try to understand different applications of normal probability curve by taking certain examples from real life situation. In the previous video, I have already discussed 4 applications of normal distribution and how normal probability curve can be used to solve problems related to these particular 4 applications. In continuation of that video, now I will be discussing the 5th application of normal distribution curve. So what is this 5th application? The 5th application is to determine the relative difficulty of the test items. So suppose a test is there and you want to see the difficulty level of a test item, then how normal probability curve can help us. To understand this particular application, we have to take a question from real life situation. So let us take a question. This is our question. The question is, in a science achievement test of class 9, question number 1, 2 and 3 were solved by 60%, 30% and 10% students respectively. So these are the test item, question number 1, 2 and 3. And they were solved by 60% of the student, then 30% of the students solved question number 2, and 10% of the students solved question number 3. Assuming the solving capacity as normally distributed, so for any application of normal distribution curve, the findings should be normally distributed. So assuming the solving capacity as normally distributed, find the relative difficulty of each question. So we need to find out the relative difficulty of these 3 items. Means in relation to each other, how much difficult they are. So how normal probability curve can be used to solve this problem?
that we will try to do now. To solve this particular problem, first we need to visualize this problem. So as we can see here, this is the normal probability curve, and we can see also that the mean is lying in this particular line here at the center. And we also know that the baseline can be divided into 6 sigmas. Similarly, we know that 50% of the cases are lying in the right hand side, and the remaining 50% of the cases are lying in the left hand side. Now, as for the first question, as we have seen in the first question, the first questions has been answered by 60% of the student. So if you can see in this particular graph, this particular region or right hand side, the students, those who have passed the items, they are in this particular region, and the students, those who are not passing or those who are having scored lesser mark, they are in the left hand side. So if we say that in the question number 1, 60% of the student has passed it, then of course this particular 60% of the cases are lying somewhere here. We can see in this particular place, because 50% we have got from this side and other 10% can come here. So 60% of the cases are in this particular region. So question number 1 can be represented by this particular area. So remaining 40% students, those who are lying in this left hand side, they have filled this particular item. Now similarly for question number 2, we have got that 30% students have passed that particular question. So of course this 30% of the students are lying, because this particular reason, this particular up to this particular level, we have got 50% students. So 30% area will be lying somewhere here. So we can say that this is the particular area under which the students, those who have passed question number 2, are lying. Similarly, for the third question, we have got this particular 10% region where the students, those who have passed question number 3, are lying. So remaining students, those who have failed this particular question, are in the left hand side. So 90% of the students are in the left hand side. We can see in this particular for question number 2 also 30% students, those who have passed, are in the right hand side, and remaining 70% are in the left hand side. So we can visualize this situation. We can see that question number 3 is the hardest one, because only 10% students have passed, and question number 1 is comparatively easier. Now we know that as we have got some percentage of cases, so we know that we have got NPC table for area under the curve. So that one we will be using to get the Z score or the standard scores. So in the next step, we will try to find out the Z score using the area under the curve or the percentage of cases under the curve. That one we will be using to solve this particular problem and to determine the relative difficulty of these items in comparison to each other. So let us see how we'll be doing that one. Now, as I told that in this particular question, further we need to find out the Z scores or the standard scores for different questions. This is the graphical representation of our findings for question number 1 that we have seen in the previous part of the video. This is the graphical representation of question number 1. So 60% students are lying here. So we need to find out the Z score for this particular cut point. So as we have got question number 1, 60% have passed this item. So the cut point lies 10% left of mean. That is 50% in the right part and 10 in the left part. As I already discussed in the previous part of this video, this is the 50 part which is totally covered on the right hand side and the 10% from the left hand side. So we can say that our sigma value or Z score value will be lying in negative area or negative sigma values we will get, because we have already covered the positive part. The positive part is already covered. 50% cases are already covered. Remaining 10% are lying in the left hand side. Now after following the NPC table to get the Z score values, we can see that this particular value for 10% of the cases is minus 0.25 sigma. So as I already told you that how to follow the NPC area table or area under the curve table or the Z score corresponding to particular percentage of cases, that I have already discussed in the previous part of the video. If you have any confusion for this particular understanding, you can revisit that section of the video and again you can watch, and I hope you will understand how to follow that particular table. So we have got the Z score value or standard score value as minus 0.25. Why minus 0.25 is coming? Because it is lying here in this particular area and it is in the left hand side from the mean. So this minus 0.25 is lying in this particular point. This particular point represents minus 0.25 sigma. So we got the corresponding sigma value for the first question, that is minus 0.25. Now we will be doing it for the second question. Here also we need to find out the Z score or the standard score for question number 2. So we have already seen that this is the graphical representation of question number 2. So here 30% of the students, those who have passed that particular item or this particular number question, they are lying in this particular area. Remaining 70% are in the left hand side. So we need to find out this particular standard score or Z score for this particular point of cut. Here whatever cut point is there, that we need to find out. We are sure here that this particular cut point is in the positive part of the sigma. So this particular standard score will be in the positive form. Let us see that this question number 2, where 30% of the students have passed, for this 30%, the cut point lies 20% right of the mean, because 30% is from this side. So it is lying right of the mean, that is 50 minus 30, that is 20%. So if you see here, this is the 30%. So if we want to see from the mean part, so this is the 20% part. In reference to this 20% area, if you follow the NPC table, we will get that the NPC table for 20% of the cases, the value is 0.52 sigma. So if you go to the NPC table and see the sigma value corresponding to 20% of the cases from the mean, we'll get the sigma value as 0.52, which we can see here in this particular graph. This is lying here in this particular point. 0.52 sigma lies in this particular point. Similarly, we can do for question number 3. For question number 3, we can visualize it in this particular figure. You can see that this is the 10% reason, means this is the reason under which the students have passed this particular question number 3. That only this 10% students have passed question number 3. So if you want to get this sigma value for this particular reason, you can see that the cut point lies 40% right of the mean, because 10% is here, so remaining 40% are in this part. This sigma is also positive because it is in the right hand side. So we can see that if we follow the NPC table for the area under the curve, so if you see that 40% area, if you see the sigma corresponding sigma value, you will get that sigma value as positive 1.28 sigma. So 40% of the cases from the mean, 40% of the cases from the mean, if you follow the NPC table, gives us the sigma value or standard score value as positive 1.28 sigma, which you can see here in this particular figure. This is the question number 3, and this particular point is positive 1.28 sigma. So we have got the 3 different sigmas or standard score value for different 3 questions. That is for question number 1, for question number 2, and for question number 3, we have got 3 different sigmas. So this we will be using it to find out the relative difficulty. Now to get the relative differences in the difficulty levels, we will see this particular, we can follow from this particular table. We can see that question number 1, question number 2 and question number 3 is there, and we have got that how many students have passed this item, 60%, 30%, 10%. These three things, these three values we have obtained in the previous part of the video, the Z values. Now if we compare, we can see that we know that this particular question number 2 is difficult than the question number 1. So if we subtract this one from this one, we'll get 0.77 sigma. Similarly, question number 3 is the most difficult one. So from this, if we subtract this one, we will get this particular value. So we can say that question number 2 has difficulty 0.77 sigma higher than question number 1, which we have obtained here. Similarly, we can say that question number 3 has difficulty 0.76 sigma higher than question number 2. We can see this one here. So we have got our result. We have compared the relative difficulty level. We can say that how much question 2 is difficult from question 1, and similarly how much question 3 is difficult from question number 2. Okay, now we will see the sixth application of normal distribution curve. The sixth application of normal distribution curve is to divide a group of individuals into subgroups according to the level of ability on a certain trait if the trait or ability is normally distributed. So this is the sixth application, to divide a group of individuals into subgroups according to the level of ability on a certain trait, and that trait should be normally distributed. So to understand this particular application, we will take one problem. So we can see that this is a problem. There was an entrance examination in 100 college students. We wish to classify them into 5 subgroups, A, B, C, D, and E. So we have to divide into 5 subgroups according to their ability. The range of ability to be equal in each subgroup on the assumptions that the trial measured by the entrance examination is normally distributed. So we have got that this particular examination result is normally distributed. So how many students will be in group A, B, C, D, and E? So to solve this particular problem, first we need to graphically represent these particular divisions. So first we'll try to see how these particular 5 divisions can be represented in the normal distribution curve. So this is the normal distribution curve, as we have already seen. This is the normal distribution curve. And we know that this baseline is divided into 6 sigmas. This particular baseline can be divided into 6 sigma, that is minus 3 sigma, minus 2 sigma, minus 1 sigma in the left hand side, and similarly plus 1 sigma, plus 2 sigma, and plus 3 sigma in the right hand side. So this is the division of a normal distribution curve. This we have seen earlier also, and we know that this is how we can divide the baseline into 6 sigmas. Now, as per our problem, we have to divide this 6 sigma into 5 parts. In our problem, we have to divide into 5 parts. The 5 parts are A, B, C, D, and E. We have got 6 sigmas, but we need to divide into 5 parts. So how we can do that one? So simple mathematics we will use. Each part will be of 6 by 5, because you just see it simply, we can see that if that's because we have got 6 sigma earlier, but we have to convert into 5 parts. So each part will be now become of size 1.2 sigma. I think you are getting this one. Earlier we have got 6 sigmas, but now we have to divide into 5 parts. So just 6 divided by 5. So we get each sigma now becoming 1.2 sigma. And that can be represented by minus 3 sigma, minus 1.8 sigma, minus 0.6 sigma, plus 0.6 sigma, plus 1.8 sigma, plus 3 sigma. You can simply see in minus 3 sigma, if you will add 1.2, we will get minus 1.8 sigma. You can see here also. Similarly, if you will add 1.2 in this minus 1.8 sigma, we will get minus 0.6. And similarly, if you will add 1.2 sigma, you will get plus 0.6 sigma and plus 1.8 sigma and last plus 3 sigma. So now we are divided into 5 subgroups. Now we can locate this particular 5 subgroups in this particular region. So we can see that this first two division in between minus 0.6 sigma and plus 0.6 sigma, this central subgroup will lie, central subgroup, that is subgroup C, will lie in between minus 0.6 sigma and plus 0.6 sigma. Now again, if you will mark this particular point and in the right hand side also this particular point, the other two groups will lie. You can see that the B will lie in the right hand side and similarly D will lie in the left hand side. So remaining two subgroups will lie in the other two portions. So A will lie here and E will be lying here. So we have got all our 5 subgroups A, B, C, D, E. Starting from this particular A, B, C, D, E, you will get all that particular subgroup. A is the highest subgroup or the persons having scoring the highest mark, and E is the subgroup, the person scoring the lowest mark. So this is our division of 5 subgroups. Now after locating these 5 subgroups in the graph, the second step is to find out the percentage of cases in grade A and E. We have seen that grade A and E are quite similar, means percentage of cases in grade A will be same as in grade B. We can locate it in this particular normal probability curve. We can see in this particular normal probability curve, this was this 5 divisions that we have converted from 6 division of 6 sigma. We have divided into 5 sigmas because we have to divide into 5 subgroups. So grade A and E are lying somewhere here. E is lying here and grade A is lying in this particular area and grade E is lying in this particular area. And we can clearly say that percentage of cases in the area A is same as percentage of cases in the area E. Now we will try to see the NPC table for area under the curve or the percentage of area under the curve in reference to the sigma. So if you see the reference of NPC table and try to see that what is the percentage of cases from mean to 3 sigma, it is 49.86. So from mean to 3 sigma, the number of cases or percentage of cases is 49.86%. And similarly, percentage of cases from mean to plus 1.8 sigma, because this is the cut mark, or you can say that from mean to this minus 1.8 sigma. From the NPC table, because these two areas are same, the percentage of cases are 46.41%. So from mean to 3 sigma, we have got 49.86% cases. And from mean to positive 1.8 sigma, we have got 46.41% cases. So if we subtract from simple mathematics, we can get the percentage of cases in A or in the subgroup E. So we can see that percentage of cases in the group or grade A, which is equal to group or grade E, 49.86 minus 46.41, that is 3.45% cases each is lying in grade A and grade E. So we have got the percentage of cases in grade A and grade E. So now to get the percentage of cases in grade B and D, because these two grade B and D, we can locate it in the normal probability curve. We can see that grade B and D are lying at these two places. Grade B is lying here and grade D is lying here. So these two particular percentage of cases are same because they are lying in between 0.6 sigma to 1.8 sigma in the both direction. Here positive 0.6 sigma to 1.8 sigma, and in the same way in the left hand side from minus 0.6 sigma to minus 1.8 sigma. So this particular grade D and grade B is equivalent or equal. The percentage of cases are same. Again, we'll go to the NPC table and we can see that percentage of cases from mean to positive 0.6 sigma is 22.57. So from mean to positive 0.6 sigma, and in the same direction here also you can see in the left hand side also, if you see the NPC table, the number or percentage of cases is 22.57%. And we have already seen that percentage of cases from mean to positive 1.8 sigma, we have seen earlier that it is 46.41. So from mean to positive 1.8 sigma, we have got percentage of cases 46.41. So again, applying simple mathematics, we can see that in the grade or in the category B and the category D, percentage of cases are 46.41% minus 22.57%, that is 23.84%. So in total, 23.84% of the cases are lying in grade B and the equal percentage of cases are lying in grade D. So we have got percentage of cases for grade B and grade D. Now the last percentage of cases in grade C, we can see in the graph, it is lying here in this particular region. We can see that this is the area where grade C is lying. And again, we can follow the NPC table. We know that percentage of cases in between mean and positive 0.6 sigma is 22.57. And because this grade is spread in both the direction up to 0.6 sigma, so we can simply multiply the percentage of cases in each direction by 2. So we'll get the percentage of cases in the group of grade C is 2 into 22.57. So 2 into 22.57%, that is 45.14% of cases are lying in grade C. So we have got 45.14% cases lying in grade C. So we have got the percentage of cases in all the groups, all the 5 subgroups. We have got what is the percentage of cases in each category or each group. Now we can use simple mathematics. We know that our total number of students were 100. So, and we have got percentage of cases in each category A, B, C, D, E, which we already found out. So using simple mathematics, we can have number of students also in each category. So in the first category, that is category A, 3 to 4 students will be there, and in same number will be there in grade E also. Similarly, in grade B, 24 students will be there, and the same number will be there in grade D also, 24. And in grade C, 45 students will be there. So from percentage, we can get the number because we have got the total number of students. So simply by just simple mathematics, we can get the number of students. So this is one of the application by which we can divide into different subgroups. If that particular trait is normally distributed, then we can easily follow from the NPC table and simply we can divide into 5 subgroups, 10 subgroups by simply following the NPC table and then by converting the percentage of cases into the number of students in each category. So this is one important application of normal probability curve. Okay, now we will see the 7th application of normal distribution curve or normal probability curve. The seventh application is to determine the percentage rank or percentile rank of the individual in his group. We need to understand that the percentile rank is defined as the percentage of cases lying below to a certain score X or a point. So what is percentile rank? It is defined as the percentage of cases lying below to a certain score or a point. So we need to understand. So we have to understand what is percentile rank first. And I hope all of you know what is percentile rank. So in the seventh application, we have to determine the percentage rank or percentile rank of the individual in the group. And by using normal probability curve, we can easily do it. So to understand this particular problem, let us take one problem. So this is our problem. In a group of 60 students of class 10, Ravi got 75% mark in board exams. 60 students were there and Ravi got 75% marks in board exams. If the mean mark of the whole class is 50, 50 is the mean mark, and SD is 10, find the percentile rank of Ravi in the class. We need to find out the percentile rank of Ravi in the class. So if he has got 75% mark, we need to find out how much percentage of students are lying below Ravi, or we need to find out the percentile rank. So let us see how we can use normal probability curve to solve this particular problem.
To solve this particular problem, first of all, we need to see it how this problem occurs in a normal probability curve visually. So we can see that this is the mean value. So we have got mean 50 as per our problem, the mean is 50. So definitely our score of Ravi, that is 75, is lying in the right hand side. So Ravi's score is somewhere here in the right hand side, because mean score is 50 and his score is, individual score is 75. Now we will use the Z score formula. That is the important formula which I am repeatedly saying that this is also one of the important formula that we need to use whenever we are doing problem based on normal probability curve. Now here X is equal to 75, mean is equal to 50 and standard deviation is 10. We have seen in our problem these things are there. So by using this Z score formula, we can get the standard score. So the standard score comes to positive 2.5 sigma. So if we want to locate this positive 2.5 sigma, we can see that it will be somewhere here in this particular place. So positive 2.5 sigma is somewhere here. So here Ravi's score lies. Further, to solve this particular problem, we need to see that this is the place where Ravi is there. Now we will see the NPC table and follow the area under the curve under this plus 2.5 sigma distribution. So using the NPC area table, we can see that percentage of cases in between mean and positive 2.5 sigma is 49.38%. 49.38%. So we have got from the area table or from the NPC area table, we have got the percentage of cases in between mean and plus 2.5 sigma is 49.38. Further, we have got 50% cases in this particular region. So total percentage of cases below score 75 is 49.38% and 50% in the left hand side. So in total 99.38% or 99%. So percentile rank of Ravi is 99th, or we can say 99% students are below Ravi. So in this way we have solved this particular problem. The percentile rank of Ravi is 99. Now we will see the 8th application of normal probability curve. This application is just an extension of the previous application. So here the application is to find out the percentile value or raw score of an individual
for his given percentile rank. So there we were finding percentile rank. Here percentile rank is given. We have to find out the raw score or the marks obtained by that particular student. We already know that the percentile rank is the percentage of cases lying below a certain score or a point. To understand this particular application, let us take one problem. So the problem is an aptitude test was administered on a large group of students of class 9. The mean and SD of the scores obtained was 65 and 15 respectively. On the basis of aptitude test, if Rosen percentile rank is 80, find what is the score of Rosen in the test. So here percentile rank is given 80, that is 80% of the students are lying below Rosen. But we need to find out what is the score obtained by Rosen. We have got the mean value, we have got the SD, and we have got the percentile rank. So let us see how we will use normal quality curve to solve this particular problem.
To solve this particular problem, let us see it in the graph first. So this is the normal quality curve, and we have got the central line. Here the mean is there. Now we have got that P80, that is percentile rank 80, definitely it lies in the right hand side of NPC, because we have got the percentile rank 80, or we are saying that 80% of the students are lying in the left hand side. So definitely P80 will be lying somewhere in the right hand side, because only 20% of the students are above this particular point and 80% are below this particular point. Now we have got the mean here, and 50% of the cases are in the left hand side. So remaining 30% of the cases are in the right hand side. So this is the particular situation, 50% and 30%. So this is 80%, 50 plus 30, 80% of the students are lying below Roshan, or this is the P80 value. Here only the score of Roshan lies, and remaining 20% are above him and 80% are below him. 80% students are below him. So let us understand again, as 50% cases lies in the left of the curve, thus the remaining 30% of the cases are in the right hand side of the mean, and we can see it in the graph. As 50% of the cases are in the left hand side, remaining 30% of the cases are in the right of the mean. So in total 80% of the students, those who are lying below Ravi, are in this particular side, left hand side, and 20% students are above him. So in this particular line represent the score of Ravi. Now to solve it further, we have to follow the NPC table, and from here we can easily see the percentage of cases from mean to this particular point is 30%. So we can easily follow the NPC table for 30% of the cases, and we can see that the Z value here is 0.85 sigma. So we can see from the NPC table percentage of cases in between mean and that particular Z score value. You can refer, and we can see that the Z value which we are getting is 0.85 sigma. So this particular point we get Z equal to 0.85 sigma. Further, to solve this particular problem, we will use the Z score formula. We know that we have the Z score formula as Z equal to x minus m by sigma. In this particular problem, we have to find out the x score. We have got the Z score. We know the mean value, we know the sigma, so we can substitute here and we can easily get the x score. So we have got Z equal to 0.85 sigma, m or mean is 65 and SD is 15. So substituting in this particular formula, we can get x is equal to 78. So we have got that score of Roshan is 78. He is at the P80 level, or 80% of the students are below him.
but actual score of Roshan is 78. So in this way, from percentile rank, we can get the scores. So this is another application of normal probability curve. We have got the score 78 of Roshan. So in this way, we have solved one problem where the percentile rank is given, and from that we can get the raw scores. So I have discussed many applications of normal probability curve. For your practice, I ask you to solve these two particular problems, basically based on 7th and 8th application of normal probability curve. So for me, 100 and SD equal to 10, find the raw scores for P75 and P50. So basically it is based on application 8 just now, which we have done. So solve this problem, and I hope we will be easily doing it because it is already discussed. So in this particular video, I have discussed about different application of normal probability curve. If you have watched my 3 videos on normal probability curve and normal distribution, you must have noticed that how important it is. The basic understanding of normal distribution and normal probability curve and its characteristics is essential to understand different problems in the field of education and in the field of research in social sciences. The essential characteristics of population and sample can be also understood if we have understood normal probability curve or normal distribution. The fundamental basis of parametric and non-parametric statistics is based on normal distribution. In fact, any type of parametric statistic is followed when the distribution follows the normal probability curve or normal distribution. In fact, we can also address the problem where the normal distribution is not there. If you understand the normal probability curve and its characteristics, and if the problem is where there is deviation from normal behavior, those type of situation also we can address if you have understood normal distribution. So understanding properties of normal distribution and normal probability curve help us to interpret our data which we have collected for our study. So I hope these 3 videos will help you to become more efficient in conducting research, or you will be able to solve different problems where the data is normally distributed. I hope you must have liked my videos, so press the like button and also subscribe to my channel. In the upcoming videos, I will be discussing on different other statistical parameters or different other statistics which is essential for conducting research in social sciences and education. So keep on watching. Thank you.